My name is Jeff Chan. I'm an assistant professor in the Department of Chemistry, and my research involves using synthetic chemistry to develop small molecules to allow us to see what has never been seen before. So in particular, what we're interested in doing is developing advanced molecules for biomolecular imaging. Imaging probes are molecules that we make in the laboratory and we use them for a defined purpose. So for example, we're able to look deep inside a cell or inside tissue to gain molecular information. So our technique is really geared towards looking at properties of disease states, for example, cancer or really deadly bacterial infections. So what we do is we leverage these pathogen or disease-specific properties and we develop these small molecule probes to be able to recognize them. So for example, hypoxia is something that we're really interested in, and this is defined as when your body has low oxygen content, and it's involved in a lot of disease states. In particular, our lab is really interested in a technology known as photoacoustic imaging. And what this technology does is it uses light to excite our molecules and it converts it into ultrasound. So what this allows us to do is to peer very deep into tissue to get information that otherwise you would not be able to see. I'm really excited about the research that we're doing here because we recognized an area that really needed advances. So the work that we're doing currently will result in major advances in the field because unlike a lot of imaging modalities that are currently used in the biomedical setting, they require harmful radiation, for example, to peer deep into the tissue. However, you're not getting a lot of the resolution or the molecular precision that you otherwise would expect. In contrast, you can use probes that are optical based and you can get very high information, high quality information. However, the imaging depth is very low. Our technology strikes that fine balance between imaging depth and molecular precision. I became really interested in chemistry during my undergraduate studies because it was an area that really allowed me to piece together all the different types of science. For many people, chemistry is considered the central science for that very reason. It connects biology, connects physics, connects mathematics, and connects medicine. And so I was really interested in using the technology that I would be developing to solve real-world problems. University of Illinois truly is a remarkable place to do research. You have very talented students, amazing collaborators, amazing faculty. There's resources here on campus that you can essentially do any type of research that you can imagine. It's truly a wonderful place to be. The future of the department, I envision continual growth. We see, again, major advances in various areas from materials to physical sciences to chemical biology to organic chemistry and so forth. And our laboratory, we want to play a role in that. We think through the development of our imaging probes, development of our techniques for diagnosis, for guiding surgery, I think we can really make a mark in this area.